Greetings friends, welcome to our channel CodeChef. Today we are going to solve the problem stacks and the problem code is STACKS. This is a simple problem with one prerequisite which is binary search. So let's move to the problem statement. Mike's favorite toy is a set of n discs. The boy likes to compose his disk in stacks. But there's one very important rule. The disk in a single stack must be ordered by the radiuses in strictly increasing order, such that the topmost disk will have the smallest radius. Now Mike processes all the given disk. Firstly, Mike initiates an empty set of disk stacks, that is, there are no stacks. But then Mike processes the disk such that if there is at least one stack, such that Mike can put the current disk on the top of this stack without making this move invalid, then he chooses the stack with the smallest top disk radius strictly greater than the radius of the current disk and puts the current disk on the top of that stack. Otherwise, Mike has to make a new stack consisting of only the current disk. Given an array of n integers denoting the radius of all the disk, we have to find the set of the stack top disk radii after the algorithm is done. Let us try to understand the problem statement with the help of a sample case. Consider the first sample case in which the number of disks is equal to 6 and those disks are 3, 4, 5, 1, 1 and 2. So he will process the disk in the given order. Firstly, he will process 3. Since there is no stack initially, he has to make a new stack consisting of only 3. After that, we have to process 4. We have to find such a stack such that the top of this stack has a disk of radii more than 4. Since there is no such stack, we have to create a new stack. After that, we have to find such a stack which has value greater than 5. But we still don't have any stack, so we have to create a new stack. After that, we get a disk of radius 1. We try to find a disk which has radius greater than 1. Since all the disks have radius greater than 1, we choose the stack which has the lowest such value which is greater than or equal, which is greater than 1, which is 3. So we put 1 upon 3 such that now the top becomes 1. After that, we search for this particular one and we find that 4 is the disk upon which we can place R1. So the stack becomes 1, 1 and 5. After which we get to process a disk of radius 2 and we have to put this disk of radius 2 upon the disk of radius 5 so that the 3 stacks become 1, 1 and 2. We can see that output has 3 stacks which are 1, 1 and 2. So this is how the disks are being processed. Let us have a look at the constraints. So there are at most 10 test cases and in each test case firstly we will be given n, which is the number of disks. This value is lesser than or equal to 10 to the power 5. After that, we are given the radiuses of all the disks and the radii of any disk can only lie between 1 and 10 to the power 9 and these radii are only integers. Let us move to the solution next. But before moving to the solution, I would like to ask you to pause the video here and try to solve the problem on your own. Let us have a look at the solution. So what we can do is we can maintain some data structure in which we will store the radius of the top disk of all the stacks. And when we process some particular disk, what we have to do is we have to find the smallest such disk which have the radius greater than this disk. If we maintain this data structure in a sorted order, we can find the smallest value which is greater than this particular disk by using the concept of binary search. So we have to maintain this particular data structure in the sorted order. What we can do is we can maintain some particular vector and in this vector all that we'll have is the radius of the top disk of all the stacks. When we encounter some particular disk, we can binary search to find the smallest disk which has radius greater than 5. In this case, there is no disk which has radius greater than 5. So we have to create a new stack with only this particular disk. After that, when we process the query 1, we have to find the smallest disk which has radius greater than 1. And in our case, that disk is 3. So what we can do is we can place 1 upon 3. And in data structure, what we can do is we can replace this 3 by 1 because we are only maintaining the top of each of the stack. So the stack would now be this. After that, when we query another one, what we have to do is find the smallest value which is greater than 1. In this case, it's 4. So the 4 will get replaced by 1. After that, we get a disk of radius 2. We find the smallest value which is greater than 2. Here it is 5. And then we replace 5 by 2. And at last, all that we have to report is size of the vector that we have created and also all the elements of this vector. So what do we have to do in binary search? So we will be having some particular vector and some particular value of x. We want to find the smallest value in this vector. This vector is in So what do we want to do in binary search? We are going to maintain some sorted data structure which will have the radius of all the top disk. Then when we encounter some particular disk, we need to find the smallest disk which has radius greater than this particular x. Consider x to be equal to 2. Then we have to find 3. And in case we don't have any particular value which is greater than x, in that case we must be reported that there is no value which is greater than this particular x. In C++, we have a function which is called as upper bound. So if we call upper bound of some particular x on a vector, what we'll get is the iterator to the point which has value greater than x. And in case we don't have any value which would be greater than x, we would return the last of this particular vector. In this way, we can simulate the entire process and we can maintain the radius of top of all the stacks by using the concept of binary search. Since binary search is the prerequisite for this problem, we can start coding now. Before starting to code, let us discuss what's the time complexity of this approach. In total, there are n disks. For each disk, what we have to do is apply a binary search on a vector which can have at most n elements. So the total time complexity would be n times log of n. So let's start coding now. So firstly, we need to take the number of test cases as our input. After that, we can take the number of disks as our input. Let us create an array of size n which we'll name as disk. After that, we need to take the n elements of our input and we can store each element in disk of I. We'll maintain the top of each stack in a vector called as top. Initially, this vector will be empty. Then we have to iterate through all the n elements in our disk array. We'll call the radius of this particular disk as rad. Then we can use the upper bound function to get the iterator to the point which is just greater than the given radius. This thing can be done by using the following syntax. top.begin, top.end, and then rad. We have to check if there is some element which is greater than this particular rad value. This thing can be checked by checking if it is equal to top.end. In such case, what we have to do is we have to push back that into the top array. Else, what we can do is we can replace the element which was just greater than this particular x by x, which is rad. In this way, our vector will be ready. In the end, we have to print what's the size of this particular vector which we have created. After that, for all the elements in the vector, we have to print this element. After each test case, we have to print an inline character. So let us try to run our code on the sample test cases. So our code has got accepted on the sample test cases. Now let's try to submit our code. Now we have to wait for the result. So we can see that our solution has got accepted. So let's try to summarize our solution. So we have taken the number of disks as our input, then we have taken all the disks in the given order. We are maintaining a vector which consists of the radius of the top disk in each of the stack. Initially, this vector is empty. After that, we iterate through all the elements in our disk array, and then we try to find the pointer to that point in the top vector which is having a radius just greater than rad. And if there is no such point, we append the value of rad into our top vector. But if there is such a value, then we replace it by rad. In the end, we are printing what's the size of the vector that we have got, and after that we have printed all the elements in this stack. After that, we have separated each test case by a new line character. Thank you. Like the video if you understood the problem and its solution. In case of any doubt, feel free to drop a comment below. Do try to submit your own solution on CodeChef after understanding the tutorial. If you are interested in competitive programming or you want to master data structures and algorithms, CodeChef is the one place destination for you. We post many competitive programming concepts and problem solving questions on our channel every week. To stay notified of the upcoming uploads, subscribe to our channel and hit the bell icon. Thank you.